welcome back to biology. It's the 26th of October, creeping up on Halloween. Very excited. We're going to do the second day of the Osmosis Lab today, where we collect all of our data. So I'm going to pull each potato out of its plastic cup, and then we're going to measure the length, and we're going to measure the mass. Before I do that, I thought you might want to take some observations of what each potato is now looking like. So let me stand here. Here's potato A. Looks like it got burnt quite a bit. Here's potato B. Much more of a French fry color. I don't know how well you can see that. It's probably better without light behind it. Here's potato C. Looks a little bit burnt. That brown color is the potato. Here's D. Looks like a potato, no coloration issues. I'll show you again when I pull them out. Here's E. Here's F. We're having a hard time seeing the potato. It's that black thing in there. So it got quite brown. No chili. Gotta stay inside. Alright, so I'm going to take some time to pull all of those out, and I'm going to pat them dry, and then I'm going to just put them on a piece of paper like this, so that you don't have to watch me pulling them out with chopsticks and drying them off. That part we can skip. So hold on one second. Okay, welcome back. So I've done a little bit of cleaning because I was really nervous that I was going to toss all of those glasses full of salt water all over my everything. So just a little preview of what I've done to set this lab up. You can see my scale here, and it's important that I used the same scale as yesterday. Maybe you guys can think about why it's important that I used the same scale. I've got my potato strips lined up here from A to F. Then I have the same ruler that I used yesterday. So I will try to maneuver this stuff around the best as I can to help you see it, but unfortunately you're not going to be able to see me. Hi. I don't know how to set it up. I need a gizmo. So let's start with potato A. So I was using these chopsticks just so that I could get them out of the water. Let's take the mass first, so that this machine just, I can leave it alone. I really need to get a new one. Okay, so I'm going to take my scale and move it in a way that you can see better. And I found that it was easier to see when I put my light on it. Okay, there you go. So, I'll just do one-handed. Okay, so potato A is pretty squishy. And potato A has a mass of, what did we decide, 5? All right, 5 for A. I'll measure A in a second. Potato B. Also 5. C. 6. D. 8. And D feels really stiff. And look, it's starting to like warp. For those of you who know anything about wood, this is E. This is potato E. Feels really fragile and squishy. It's got a mass of 4. And F mass of 6. Okay, I'm just going to measure A and B one more time, just because they're the same, and I want to measure them all again. Let's see what we got. So 6 for A, my second time measuring. Oh, 6 or 5. Maybe we could call that 5.5, since it seems to be waffling between 5 and 6. All right, for B, five. And it's staying at 5, so we'll keep it at 5. C, just dry this off. C is 6. That's what we got last time. 6. Okay. 5.5. D, 8. E, 4. F, 5. 5. We'll measure this one more time. Why did I wipe it off in the middle, do you think? Six. 5. 6. That one looks like a 5.5 too. Okay. Now, ideally, I'd run these numbers one more time. But for now, I'm going to leave them. Let's run A and B again. Let's run A and F. I mean, the two that are the same. I got a 6 this time. 5. Okay. 5. Tearing it means I'm bringing the scale back to 0. I think we're going to go with 5.5 on this one. All right. All right, so let me set up for measuring. 1 second. Welcome back. We're going to measure the length of these potato pieces now. So while I'm doing this, consider if it took water on, what should happen to the length? If it lost water, contrastingly, what would happen to the length then? So let's compare what we get. I hope you can see this. This is A. Okay. So A is 2.5. This is how I'm doing it. A is 2.5 inches. Pretty much right on the money. All right, so I'm writing that down over here. A is 2.5, 2.5 inches. Okay. And then B was 2.5, 2.5 as well. actually warped. The shape of it is not flat anymore. It is warped. And if you know anything about wood, what happens when wood takes on water? Okay, so depending on how I lay it down, which is a little hard to do, it is almost 3 inches. So it's 2 and okay. So I'm going to go with 3/4, 2 3/4 still, a little bit more than that, but not enough to hollow. So we're going to go with 2.75. Here's E. So E is it's right on the line at 2.5. And F is 2.5. So this showed us something, right? And one thing I'd like to point out is I don't know how well you can see these potatoes. I hope really well. But while I have you here on the camera before I pause for the next thing, I want you to just compare the size of these potatoes. Compare the size of these potatoes for me. Look at how big E is. Or I'm sorry, D slide. Look at the size of D and E. These started off the same size. I promise you I measured them exactly the same. So look at D and E. Significantly bigger. Significantly bigger than any of these. It's not just longer, but it's wider. Okay? So keep that in mind. Now, there was some salt in 5 of these solutions. So you just have to figure out which one had the least amount and which one had the most amount. And the way that you're going to do that, if you remember, if this is our data sheet, you have to do some simple math here, okay? And I'm not going to give you the answers because this is something you should be able to do at this point. But you have to calculate the final, or the change in mass. So it even tells you take the final mass here, subtract the original, or initial, right? And the same thing for the length. Now this is only going to change with one of them. And that should be a visual clue for you for which one didn't have salt. And then over here what I want is a number. I only want a number 1 through 6. Okay? So that's why I changed these to letters over here. So if you decide that green, or what was supposed to be green but we used B, was going to be the one with no salt, then that would be number 1, hypothetically. I'm not saying yes or no. If you decided that purple, F, had the most salt, then you'd put 6. So if you look up here in your directions where it says, use this data to number the solutions in order of increasing salt concentration, number 1 contains the least amount of salt, that would be none. Number 6 contains the most amount of salt. Okay, so you need to figure out which one was which. And then we'll go over again how to answer the questions, but you don't need me for that, okay? I have faith in you. But we're going to talk about it in class, so I'll see you back in the class.